Hello everyone, welcome to my YouTube channel. In today's session, I'm going to solve paper 21 0620 May June 2023. This paper having the time 45 minutes and the students will have to solve all the paper in 45 minutes. There are 40 questions in this paper. You have the four options A, B, C, D, and select the appropriate answer or correct answer from four options. You can use the soft pencil. You're not allowed to use the correction fluid. Do not write on any barcodes. Calculators are allowed. So 40 marks, rough working can be done on this question paper, and the periodic table is printed on the last page. So the students can get information from the periodic table to answer some specific questions. Let's start from question number one. The diagram shows the results of dropping a purple crystals into the water. We have a purple crystal, and if it is dropped into the water, ultimately after 5 hours, we're getting the purple solution. So dissolving is there. So this purple crystal dissolves in water to get purple solution. So you can eliminate the A and B because in A and B, these options show that there's not dissolving. So dissolving is there. Purple crystal dissolves in water to give purple solution. So you can eliminate AB. The second thing is diffusion. Yes, the solid diffuses into the liquid to get purple solution. So you can eliminate the C as well. Chemical reaction. And this is not the chemical reaction. If you want to dissolve this purple solution into the water, you will get the purple solution. So this is a physical change. So that's why the appropriate answer is D. And in your syllabus, the purple crystals is of KMNO4. This is potassium manganate salmon. This compound is potassium manganate salmon. And salmon is the oxidation state of manganese. So in this paper, I'm also giving you some extra information. So by using those information, you people will be able to solve some other question papers as well. Question number 2 is regarding the elements, mixture, and compound. So which row about elements, mixture, and compound is correct? So element, is made up of, this is a pure substance which is made up of same kinds of atom. Mixture is an impure substance which is made up of in an unfixed ratio by mass of the different elements or compounds. The compound is also a substance which is made up of elements, and elements react together in a fixed ratio by mass to get compound. So the metallic element, brass is a mixture. So you can eliminate the brass, B and D. So these two answers, they can be eliminated. Non-metallic element. Methane, is a compound. Methane is CH4, so you can eliminate the A as well. So C is the answer. Now, we can see the rest of the options. The copper, copper is the metal. This is the metal. Sulfur is the non-metal. Brass is a mixture, and methane is a compound. So C is the appropriate answer. Let's move to the next part. The atomic structure of four particles, W, X, Y, and Z are shown. So electron, neutron, protons. Now, which particles are isotopes of same element? Isotopes are the atoms of the element having same proton and electrons, but they have the different number of neutrons. If we look at the proton, because proton is the identity of an element, so W and Y, they have the same proton. Then they have the same electrons as well. So 2 proton, 2 electron, 2 proton, 2 electrons. As the neutron number is different, so that's why these two are the isotopes of the same element. So W and Y, they are the isotopes of the same element. So B is the correct answer. Then the next part, which statement explain why isotopes of the same element have the same chemical properties? So same chemical properties mean same number of electrons in outermost shell, or you can say that same electronic structure or same electronic configuration. So if the atoms of the different elements, if they have the same electronic structure, same electronic configuration, or same electron in their outermost shell, they must show the same chemical properties. So just look at the options. They have the same number of outer shell electrons. Yes, this is the answer. They have the same number of neutrons. Neutrons are not concerned with the chemical properties of the elements. They have different number of protons. Protons are not concerned. They have different mass number or the nucleon number. This is not the option. The next question is nitrogen forms a nitride ion with the formula N3 negative. Which particle does not have the same electronic configuration as the nitride ion? If you look at the periodic table, Al3 positive, 13 is the proton number. Al3 positive mean loss of 3 electrons. So this Al3 positive, it has 10 electrons. Cl negative, 17 is the proton number. So chlorine gain 1 electron to become chloride. 18 electrons are there. Na positive, 10, 11 is the proton number. So Na positive contains 10 electrons. 8 is the proton number of oxygen. So O2 negative mean 10 electrons. Which particle does not have the same electronic configuration? 7 is the proton number of nitrogen and it has 10 electrons. So if you look at the option A, C, and D, they all have 10 electrons. So B is the different. Cl negative, it has 18 electrons. So this is the different. And this particle does not have the same electronic configuration as the nitrite ion. So B is the answer. Which row describes the formation of single covalent bonds in methane? Methane is CH4. So carbon makes 4 single covalent bond with hydrogen. And this covalent bonding is the sharing of electrons. So electrons are transferred. This is not the case. Electrons are transferred. So you can eliminate C and D because electrons are shared. They are not transferred. Atoms share a pair of electron. Atoms share a pair of electron. Yes. Now, both atoms gain a noble gas electronic structure, or both atoms have the same number of electrons in their outermost shell. The purpose of the bonding that both atoms must gain a noble gas electronic structure. So this is the appropriate answer. Both atoms have the same number of electrons in their outermost shell. And this is not possible because now hydrogen, when we share a pair of electron here, hydrogen has 2 electrons and carbon has 8 electrons in its outermost shell. So A is the answer, that covalent bonding, atoms share a pair of electron and both atoms gain a noble gas electronic structure. The next part. Which formula is an empirical formula? Empirical formula is the formula which shows the simplest ratio of atoms. Now, if we look at the A option, 2, 4, 1, 2, 4, 1, we cannot simplify anymore. So this is the answer, but just look at the next one, 4, 8, 2. We can simplify this formula as a 2, 4, 1. So this will be the empirical formula if we write with 2, 4, 1. Now, if we count the total number of carbon, hydrogen, and oxygen, CHO, there are uh, 4 carbon, and then 8 hydrogen, and then 2 oxygen. So this can be simplified like because 4, 8, 2. So 1, 4, and 2. So this will be the empirical formula. Like if we write C2H4O, this is the empirical formula. This is the molecular formula because it shows the actual number of atoms of every element. 1, 2, 3, 4. There are 4 carbon and then 3, 8 hydrogen and 1, 2. Okay, 2 oxygen. We will get the same empirical formula. So this A formula cannot be simplified anymore. So this shows the empirical formula. The rest of the options B, C, D, they are the molecular formula because they can be simplified anymore. This question is regarding the moles or the stoichiometry. There's a reaction between iron sulfide and oxygen to get iron 3 oxide and sulfur dioxide. The question is that what is the maximum mass of the sulfur dioxide produced from 120 kg of iron sulfide? To solve this question, you can make a mass-mass relationship because the answers are in kg, so no need to convert to in grams. If we consider these two reagents like FeS2 and sulfur dioxide, we can solve these questions. Uh, for example, there are 4 moles, so just consider the stoichiometry of the equation, the coefficients which are used before the formula. 56 is the AR of iron and 32 is the AR of sulfur. So 56 plus there is 64, but you have the 4 moles. Here 32 plus 16 times 2, and then 8 moles are there. So 8 times 64, 4 times 120. So 4, you can say 480 kg of FeS2 can produce 512 kg of sulfur dioxide. So if you use the 120 kg, how many kg of sulfur dioxide can be produced? So if you cross multiply this 512 times 120 by 480, you will get the answer. So 128 kg can be produced. The next question is regarding electrolysis. Which substance produces hydrogen and bromine when electrolyzed? This is the reactivity series of cations and anions we can use for this. Without reactivity series of cations and anions, we can answer the products of the electrolysis at IGCSE level. But just look at the reactivity series of cations and anions. Uh, the A option is concentrated aqueous copper 2 sulfate. So if you have a concentrated aqueous copper 2 sulfate, you know that there are 2 types of ions. H positive from aqueous and Cu2 positive ions are there. Then OH negative and Br negative ions are there. So if we use the concentrated aqueous copper 2 bromide, now the copper is below H positive in the reactivity series. This is the position of copper. So Cu2 positive ions are reduced. So we will get copper metal and the next concentrated aqueous copper 2 bromide. In the concentrated solution, the more reactive or the ion which is present above, that will be electrolyzed. So we will get the two products by electrolyzing the concentrated aqueous copper 2 bromide, copper and bromine. Concentrated aqueous sodium bromide. So in this case, we will also get hydrogen, H2 and bromine. Uh, then dilute aqueous potassium bromide. In dilute aqueous potassium bromide, we will get hydrogen and oxygen. Molten lead to bromide, the products are bromine and lead. So this question was that which substance produces hydrogen and bromine? So this concentrated aqueous sodium bromide can produce hydrogen and bromine at electrodes during the process of electrolysis. The question number 10 is, which statements about hydrogen as a fuel cell are correct? Water is formed. Yes, water is formed as the only waste product. Yes, hydrogen combines with the oxygen to give water. So water is the only product formed when hydrogen combines with oxygen in the fuel cell. This is correct. As you can see that the first option is correct, and C and D, they can be eliminated because there's these two options does not contain one. Then both water and carbon dioxide are formed as a waste products. Carbon dioxide is not formed. The overall reaction, yes, this is the overall reaction. The overall reaction is endothermic. No, the overall reaction is exothermic. That produces heat, and that heat is used in the fuel cell. Uh, so the option A is the correct answer. Now, 11. This is regarding the uh, enthalpy changes. So this reaction is between C2H4 and oxygen to make carbon dioxide and water. So if you want to get the enthalpy change of this reaction, you should draw the structures of reactants and the products. So these are the covalent structures. C2H4 is ethene. This is the covalent structure of ethene. There is one CC bond. There are four CH bonds are there. So I have already written here. Then oxygen is a molecule which contains double covalent bond, but three molecules are there. So three times O double bond O. So the formula for the enthalpy change is that the enthalpy change which is required to break bond minus bond formed. So bond broken minus bond formed, and we'll get the enthalpy change or the energy change. On the right hand side, carbon dioxide, this is the structure of carbon dioxide, but two coefficient is here, but C double bond O. There are two bonds of C double bond O in carbon dioxide. So this is the best way that use the copy the same coefficient 2, which is before the carbon dioxide, and how many bonds are there? Then you can write the number here, C double bond O. There are two bonds, and the two coefficient is before the carbon dioxide. So there are four C double bond O are there. The same is the case with the water. You have two, and then two bonds of HO. So total there are four HO bonds. So C double bond C614 is the bond energy, C double bond C. Then CH is 413. So this is 413 times 4. And O double bond O is 495. So 495. O double bond O, 495. Yes, 495 is the energy. Then minus 2 times 2, 4. 4 times 799, which is the bond energy of C double bond O. And 4 times HO. HO or OH is 467. So if you calculate the bond energy, which is required to break all the bonds of the reactants, minus bond energy, which is released during bond making, you will get the answer like so. This is the answer for this question. Uh, just use the calculator to answer this question. You will get the answer C. Let's move to the next part. Which row describes the effect on the activation energy and the frequency of particles collisions when the temperature of a chemical reaction is increased? Activation energy is not affected by the increase in temperature. It is only affected by the by using the catalyst. So if you use the catalyst, that lowers the activation energy. Frequency of the particle collision, yes, that will increase. So if the kinetic energy of the particle will increase, particle will start moving with a rapid pace, and there must be more collisions per second. So we can say that activation energy is not affected by the increase in temperature. So increases, you can eliminate this answer. Increases, A and C, they must be eliminated. Then no change, okay, no change. Then frequency of the collisions, definitely that will increase when you increase the temperature. The particles gain more kinetic energy. They will start moving with the rapid pace, and the number of collisions per second they will increase. So B is the correct answer. The next one is solid copper 2 sulfate exists in the two different forms, hydrated and anhydrous. One of these form a blue and the other is white. So the hydrated copper 2 sulfate is CuSO4.5H2O, and anhydrous copper 2 sulfate is CuSO4. And then if we heat this hydrated copper 2 sulfate, we will get copper 2 sulfate anhydrous plus water. So this is hydrated copper 2 sulfate, and this one is anhydrous copper 2 sulfate. Hydrated is blue, and the anhydrous is white. And if we heat the hydrated compound, we'll get the anhydrous compound. So this is white and this is blue. The reverse sequence can be used to test the presence of water, that if we add the water on white crystals of anhydrous copper 2 sulfate, we'll get the blue. So water turns the anhydrous copper 2 sulfate from white to blue. This is the test for water, but according to this question, the blue form is hydrated and the white form is anhydrous. So what is the blue form? So blue form is hydrated and this is anhydrous. So hydrated form is blue, and if you want to convert or change to white form, you should heat. So 13 is D. Then sodium ions and oxide ions combine with the chromium ions to form a salt. The salt is sodium dichromate, but it's the oxidation state of chromium. Yeah, the sum of oxidation states of all the elements is 0. So here we have the 2 sodium ion, 2 chromium, and 7 oxygen. That is 0. Sodium is in group 1, so we can say the +1 is the oxidation state, but we don't know the oxidation state of chromium. So 7 atoms are there. Every atom is -2, so 0. +2 plus 2 Cr minus 14 is 0. So 2 Cr minus 12 is 0. 2 Cr is 12, and the oxidation state of 1 chromium is 6. So +6 is the oxidation state of chromium in this compound. So this is sodium dichromate. This is sodium dichromate, and we can also say to sodium dichromate 6, because 6 is the oxidation state of chromium. So C is the answer. The concentration of hydrogen ion in 100 centimeter cube of 0.1 moles per dm cube hydrochloric acid, this is a strong acid, is higher than the concentration of hydrogen ion in the same volume and same concentration of ethanoic acid. So this is ethanoic acid. Uh, Hydrochloric acid is a strong acid which completely ionizes in an aqueous solution. So its degree of ionization is 100%. Ethanoic acid partially ionized. So that's why when it partially ionizes, and if you have the same number of moles, that will produce less number of H positive ions. So which statement explains the difference in the hydrogen ion concentration? Ethanoic acid is partially dissociated. So ethanoic acid is partially dissociated. So that's why we can say that it will produce the less number of H positive ion, because the weak acids are the acid which gives the less number of hydrogen ions. Now, the next one. Which oxide is classified as amphoteric oxide? Aluminium oxide is the amphoteric oxide. Calcium oxide is the metal oxide. This is basic. Copper 2 oxide is also basic, and nitrogen dioxide is acidic. There are some more oxides which may be amphoteric. So there are 3 oxides in your specification: aluminium oxide, lead oxide, and zinc oxide. They are the amphoteric oxide. So basic oxides are the metal oxide, like group 1, group 2, copper, iron, and the non-metal oxides are acidic, like nitrogen oxide is acidic. So A is the answer. So in the next question, which method produces the salt copper 2 carbonate? Copper 2 carbonate is CuCO3. Just look at the different options. Add copper 2 oxide to the water. Copper 2 oxide is insoluble in water. So then add excess aqueous sodium carbonate. So it is insoluble in water. So copper 2 oxide is a basic and sodium carbonate is also basic. So they cannot react. So A is not the answer. Add copper 2 oxide to dilute sulfuric acid. This is basic. This is acidic. They both can react to give copper sulfate and water. Then add excess aqueous sodium carbonate. So if we add the excess sodium carbonate in the copper 2 sulfate, the displacement reaction, double displacement reaction will be there, and the copper carbonate and sodium sulfate will be formed. So filter off the precipitate. This is the precipitate, and we can get the precipitate. And B is the correct answer. Add copper to dilute hydrochloric acid. Copper is below hydrogen in the reactivity series, so copper doesn't react with the dilute hydrochloric acid. Add copper 2 oxide to excess sodium carbonate. Copper 2 oxide is basic. Sodium carbonate is also basic, so they cannot react with each other. So D is not the answer. Then, which statements about the trends across a period of the periodic table are correct? So aluminium is more metallic than sodium. Aluminium is less metallic than sodium. Sodium is more reactive. So sodium is more reactive, aluminium is less reactive. So A will not be the answer. So you can eliminate these two options. Beryllium is more metallic than carbon. Yes, you can say that beryllium is metal and the carbon is non-metal. So beryllium is more metallic than carbon. This is a correct statement. Boron is more metallic than lithium. This statement is not correct. Lithium is more metallic than boron. So you can cancel this. Magnesium is more metallic than silicon. Silicon is a metalloid. Magnesium is a metal. So 2 and 4. This is the correct answer. Then some informations about elements in group 2 of the periodic table are shown. So elements, beryllium, magnesium, calcium, strontium, barium, and time taken for to make 10 centimeter cube of hydrogen gas when 1 gram of metal is added to the cold water, density in grams per centimeter cube, and melting point, which row shows the correct trends in the reactivity, density, and melting point of the aluminium. So if we look at the data which is obtained when hydrogen time taken to make 10 centimeter cube of hydrogen gas when 1 gram of metal is added to the cold water. So the metal, when they are added into the cold water, will get metal hydroxide and hydrogen gas. If you look at the data, the time taken, the beryllium, no reaction. Okay, magnesium, 300 seconds, calcium, 60 seconds, strontium, 30 seconds, and barium, 10 seconds. So when the time decreases, it means that less time is required to make the hydrogen gas. The reactivity of the metal increases. So the reactivity that increases from top to bottom. So decreases down the group, you can eliminate this answer. Then decreases down the group, you can eliminate this answer. Increases down the group, okay, increases down the group. Then density. If we look at the density, 1.85, 1.74, then 1.54, 2.623. Oh, there is no clear trend. So, okay, C and D, no clear trend, no clear trend. Just look at the melting point of this. So melting point is, so the melting point, as we can see, 1280, 650 decreases, then increases, then decreases, then decreases. So no clear trend about the melting point of group 2 elements. So uh, D is the appropriate answer. Now, the question 20, mm, the a new element, oxfordium OX, was discovered with the following properties: the solubility insoluble in water, electrical conduction, does not conduct. Formula of the element. This is the diatomic bonding in the molecule of OX2. There is a triple bond. In which group of the periodic table should the element be placed? Group three elements, generally they are metals, so they do not exist in the form of two atoms joined together. So this is not possible. Group eight elements do not react. So five and group seven they are possible because they exist in the form of two atoms joined together. Uh, no, does not conduct electricity. Okay, solubility insoluble in water. Generally, halogens they may be soluble in both aqueous and organic solvents. The group 5 is possible because there is a triple covalent bond, and group 7 elements they can make a single covalent bond. So this is possible that group 5 elements they can make the triple covalent bond between two atoms joined together. So B is the appropriate answer.